page 575, and we're going to talk about volumes of cylinders. So yesterday you did a worksheet finding the surface area and the volume. Surface area is a little tough because you got to find so many different things and add them up. You got to know what you're looking at. But the volume is just simply area of the base, that's capital B, times the height for your volume, for your cylinders and your prisms. So on this page, it asks, what information would you need to calculate the volume of each solid? Well, this is a cylinder at first, on the first one, and you need capital B. For the capital B, you need the area of the base, which is pi r squared. So you would need your radius. And then the height, you would need this. And for the prism, you would need the area of the base, which would be the length and width, or base times height, whatever, of the base. And then you would need the height of the whole prism. And then it says, what is the same and different about how you would find the volume of each solid? Here's where you would just normally skip this question because you had to write words. But I want you to put in words what's the same about these two in the formula, what's the same that you need and what's different than you need. Put that into words. On the next page, there are two containers. One's a cylinder, one's a prism. It says the measurements are in centimeters. So the first question says, suppose the prism contains water that reaches a height of 1 centimeter. Prism's on the right. That water reaches the height of 1 centimeter. Draw a representation of this situation. So really, all you have to do is, hey, here's my water, and then put 1 beside it. That water reaches 1 centimeter. On B, it says the water is poured from the prism into the cylinder. What is the height of the water in the cylinder? Well, we need to first do some comparing of the two. Let's look at the area of each base. So on the cylinder, the area of the base is pi r squared. So 6 is our radius, so 6 squared is 36. So area of the base is 36 pi. Let's look at the area of the base of the prism. That is base times height. Well, in this case, our base is 4 pi. Okay, we don't see that much, but it happens. So 4 pi times 9. 4 times 9 is 36. So we have the same area of the base. And look, our heights are the same. So if we were finding the volume of these, that would both be 360 pi. So we have the same volume. We have the same area of the base. Sometimes if our area of the base is bigger on one, then the water would be less in the other one. But since the area of the base is both, on B it says what would happen if you poured it in. It'd be the same height. You'd still get 1 centimeter of water because the area of the base is the same. So on B, I want you to write in words, it would be the same height. Okay, and then number 2 says, suppose the prism contained water that reached a height of 3 centimeters instead of 1. So you have more water. It's reaching 3 now. Okay, not 1 anymore. What would happen if you poured it into the cylinder? We haven't changed any sizes between the prism and the cylinder. So if you have 3 in the prism, what would you have in the cylinder? I need you to write that in words. Moving on to the next page, it says, suppose each two-dimensional figure is rotated around the vertical axis shown. If you remember, if you were here that day when we returned back, we had a shape taped to a straw, and we turned it and we figured out what solid it made. So this is the same kind of thing. We know that B is going to have a hole in it because it is not attached right here. So it's going to be a hole, kind of like that donut we had to draw, and it was just a circle, not attached. So there's going to be a hole. And then we know A is going to be like a 2-level. Remember the cake we had to draw half of? And it had three layers to it. So this one's going to be like a 2-layer cake. So instead of sketching it myself, which I want you to sketch this, I'm just going to show you the real picture of it. So kind of sketch that out, pause it and sketch it out. And then we're going to move on to number 2. Okay, then it says find the solids volume. So on the first one, it's just simply 2 cylinders. There's a cylinder here, and then there's a cylinder here, and we're going to add them together. So let's look at this. The cylinder of the top one, remember it's capital BH, so pi r squared times the height of the cylinder. So 2 squared, 2 is my radius in that top one, times 3 is the height. So 2 is my radius, 3 is my height. So I get 4 times 3 is 12, and I'm just going to keep pi in there. That's of the top one. This is cube, sorry. Centimeters cubed. We're talking about a 3-dimensional object. And then the second one, my radius is not 3 because we've got to also add this radius. And if this radius is 2, this radius is also 2. So the radius of the large bottom one is 5. Because 3 plus 2. And the height is 3. So 5 squared is 25 times 3 is 75 pi. And we're just going to keep pi as pi. This gives me an exact answer. We can always multiply that out on our calculator. But now we have to add 75 plus 12, and you get 87 pi, and this should be cubed, sorry, centimeters cubed. It's kind of like when we have 2x plus 3x, we can add the 2 and the 3. But if we had 2x plus 2y, we couldn't add them. Those were not like terms. So if my centimeters cubed on both of these, we can add them. If one was squared, like if it was area and volume, I can't add those. Those aren't the same things. What you're going to do on this second one is find the volume of the entire cylinder. But in order to find the volume of the whole thing, you're going to need to find the radius of the entire thing. It's kind of like the first one, when you knew the radius of the small one and the radius of the large, part of the radius of the larger one, and you add them together. Same thing here. You're going to find this plus this is 5 centimeters. So 5 squared, and my height is 6. Then you're going to find the volume of the whole, which is going to be 3 squared times 6. And you're not going to add them, you're going to subtract them. So once you find each one of those, subtract them. Keep pi as pi. That makes it an exact answer. If your answer choices were a decimal, then you can easily put 87 times pi in the calculator and figure out the decimal. This picture, or this graph, gives us the one on the right, just like the one right before this. Without it touching the axis there, it gives us a hole in it. So this would be the radius part of the solid part, and this would be the radius of the hole, and you'd have to add those together to give you 4, and then your height would be this. So you'd do pi 4 squared times 5 on that, and then you'd have to find this center part and then subtract it. So anytime there's a hole, you're going to subtract it. Anytime there's layers like this one, you're going to add those together. So let's go to our purple pages. And number 1 says each small square represents 1 square centimeter. Sketch and label the solid. So you don't have to do it laying down. You can do it like this. And my radius would be 3. And you're going to do this a little bit neater than me. And my height would be 1, 2, 3, 4, 5, 6. And then you're going to find the volume. Capital B times H. And my capital B is pi r squared times the height of the height of the cylinder. So on number 2, it says match which one of those goes with it. You're going to have to count some blocks and see which one goes with what. On this next part, on number 3, it gives you what the radius of the base would be, the height of it. So remember, you're going to do this because this part is capital B and there's my H. Keep it in terms of pi. Don't multiply pi out. And on C, it says a hexagonal prism whose base area is 30.5 and whose height is this. So capital B is already given for you. And here's my height. So you just multiply those together. And right triangle on this one with the legs of this and this. So this would be my little b and my little h. And here is the h, the height of the prism. So you're going to go capital B, which is my little b, my little h, times the other height. And since we're multiplying all these, it doesn't really matter what goes first or not. But remember, capital B is 1/2 that. So 6 times 7, and then take half of that, and then multiply it times 5. Okay, we're going to skip number 4. And let's look at number 5. A toothpaste manufacturer wraps its boxes in plastic. Its most popular toothpaste comes in a box that's 8 centimeters tall and uses this much of plastic wrap. The company sells a travel version of the toothpaste in a box that's a dilation of the original box. The travel version uses this much. How tall is the travel version's box? So we're going to have to find the scale factor and then figure it out. So we're going to take our original surface area, which is this, and we're going to divide it into our new surface area. And we're talking about surface area because that's how much it's wrapped. So we take 306 divided by 1224. And we get 0.25, and because it's area, we're taking the square root of that. So the square root, we go second x squared, 0.25, and we get 0.5. Okay, that is our scale factor. So if we multiply our original height, 8, by 0.5, that's like multiplying it by half, you get this. It makes sense because this is smaller than the original, and if you look here, the new one's smaller than the original, and our scale factor is less than 1. Let's move on to number 6. A solid with the volume of 32 cubic units is, here's volume is important, is dilated by a scale factor of K to obtain a solid volume of this. Find the value of K. So we're going to take our new over our original, and because it's a volume, whatever that equals, we're going to take the cubed root of it. And to find that on your calculator, you're going to hit 3, and then the second button, and then you're going to hit this button. It's under pi. And then you're going to put whatever this number is here. And then that will give you a decimal. So you're going to then divide these out, because it's not this one. You're going to divide these out on your calculator and figure out which one of those equals the decimal you got there. On number 7, it says a cube has the edge length of 4 inches. Find the surface area. So how many faces are on a cube? There's 6 faces. They are all the same. They're all squares because it's a cube. And they're all 4 by 4s. So you're going to go 4 squared gives you 16. Then multiply that times 6 to give you your surface area. And then it is inches squared. Then it says it's dilated by a scale factor of 0.25. Find the surface area. So you're going to have to go 0.25 squared, then multiply it by your original, and it gives you that. Oh, and the volume here. Volume's easy. We're just going to go 4 cubed to get our volume. And so also then multiply it by this to get our surface area is here. And this would be our volume. I don't need all these arrows. I need you listening to me and doing what I'm saying. All right, when you get done with this, make sure you do your cool down. Some of you are still making zeros because you're not going to do that. Staple these, put your name on them, and turn them in.